Hey, College Math, welcome back. Here is our last section for Chapter 5. We're looking at 5.7, which is our third part of our loans conversation. And we're looking specifically at credit cards today. Okay, so we're going to go ahead and describe what credit cards are for those of you who, you've heard of it, maybe you don't know exactly like the difference between a credit card and a debit card is. And we're going to solve problems involving credit cards. Okay, so let's just kind of start with, what is a credit card? Like if you've heard of it, but maybe you don't know exactly what it does, let's kind of go ahead and talk a little bit about what a credit card is, right? So it's a physical card that you can use to make purchases, pay bills, etc. There's lots of things you can do with a credit card. Almost whatever you can do with a debit card, you can also do with a credit card. The main difference is that with a debit card, it's money that you actually have. Think of it as, it's like cash, but you have it in card form. Whereas a credit card is not, that money is not something you necessarily own or have. It's technically money that you borrow. Okay, so it's kind of a big but here, but the money you use must be paid back. So really, we can think of a credit card as kind of a short-term loan. That's why we're kind of grouping it in our loan section of our chapter 5. Because you can really think of it as kind of a loan, more of a short term. You're not spending as long paying off a credit card as you would like a student loan or a car loan or a mortgage, right? A couple other things, the amount you can use depends on the credit limit. Okay, so credit limit is pretty much, here is the credit card. Right now, you can only spend $500. So that means that once you hit $500 on that credit card, on that loan, then you can no longer use that credit card until you've paid it off, okay? And then interest gets charged at the end of the month. Okay, and so credit cards operate on a monthly basis. You get charged interest on them every month, which is good because that kind of means, and you'll kind of learn more about this when we do the credit card project here in a few days. If you pay your credit card balance off before the end of the month, before they charge the interest, then you don't get charged interest, right? So if you spend $100 and you pay that off by the end of the month before the next cycle, next billing cycle, then you only pay 100. You don't have to pay the extra interest that comes with it, right? Cool. So there's kind of just a few more things about credit cards. You'll learn more when you do some research for that project, okay? And before we hop into some examples, I'm going to give you here a new formula. Okay, this is going to be our last formula, I promise, for this chapter. Okay, I'm going to move to the left here a little bit. Okay, and this formula is going to be really helpful for us to solve for the amount of time it takes to pay a loan off in general, but we're going to be using it for our discussion of credit cards, right? So I have capital N is equal to negative log of 1 minus, here we have a fraction, we have R times P in the numerator, divided by N times PMT in the denominator, divided by log of 1 plus R over N. Okay, so here is a new formula. And all these variables are the same from what we've done so far. Okay, R is still the interest rate, P is the loan amount, what we're trying to pay off, PMT is our payment, N is the number of payments we make in a year. Now the new one here is the capital N. Okay, that's kind of one we haven't had before, and it is different from the lowercase n, right? So capital N and lowercase n are different. So capital N is going to be the number of payments payments made over the life of the loan. Okay, so it's the total number of payments that you pay on the loan. It's not, that's how it's different from lowercase n, where lowercase n is just the number of payments you make in one single year. Okay, so that kind of is a little convenient for us because that means capital N is equal to n times t. Okay, so whenever you see that nt in our formulas, that's our capital N. Okay, that's kind of a short way for, that's kind of another way for us to think about n. You can get capital N by multiplying the n, small n, by t. And so this is a nice formula for us to use. This is pretty much the loan formula solved for NT. Okay, and so whenever I asked you to find the amount of time it takes to pay off a loan or the number of payments it takes to pay off a loan, we can use this formula. Okay, so yeah, this kind of formula answers the question. So whenever you see kind of the questions like how many payments will I need to make to pay off my loan? Okay, questions like that is this formula can answer, okay? All right, let's go ahead and jump into our example. Andrew recently used a credit card to buy a new laptop for school. He ended up charging $1,249 to his credit card, which charges 23.24% annual interest. Okay, the unfortunate thing with credit cards is that that's kind of where we start to see these big interest rates, okay? This is, we haven't seen an interest rate like this of this size so far, okay? And I pulled this straight from, a credit card that I Googled online, one of the, most well-known banks from those. So it's definitely a realistic number, okay? First part, how much must Andrew pay towards his credit card balance? Credit card balance being the total amount that he has charged right now every month in order to pay off in 1 year. Okay, so how much must he pay every single month? That means that we're looking for a PMT. So I need to use the formula that we used before already. Our PMT equals P times R over N over 1 minus 1 plus R over N raised to the negative NT power. Okay, now I can, kind of like we talked about above, I can put capital N here in place of NT. I don't really want to because I'm not given the number of payments. Okay, that capital N is only for convenience in the formula above. Here we're just going to leave it as NT. Okay, so let's go ahead and plug in our variables here, our values for each variable. We have P is our 1249. That's how much we're trying to pay off. Our R, our percentage, our interest rate here, 23.24. So that as the decimal is 0.2324. And we're doing a monthly payment, so 12. And then T, we're trying to pay this off in 1 year. Okay, so let's go ahead and write this out. Oops, come back. There we go. Do it in purple again. So PMT is equal to 1249 times 0.2324 over 12 divided by 1 minus 1 plus 0.2324 over 12 raised to the negative 12. It's just going to be 12 times 1 here. Okay, so that's your setup. Go ahead and try plugging that into your calculator. Hopefully you've gotten the hang of it by now, okay? But again, just like in the past, if you're plugging this in while you're watching this, you get something completely different, don't hesitate to ask me in class for some help to see kind of what went wrong with the calculator. We should be getting that our monthly payment has to be $117.65 for him to pay this credit card off in 1 year. Okay, not too bad. Instead of having this kind of means, instead of having to spend $1,249 right there, you can go ahead and take it with you as long as you promise to. And the funny thing about credit cards is that there's no time limit. They never tell you have to pay this off in 1 year. They just kind of tell you this is how much you have to pay. And so here, if Andrew wants to finish this off in 1 year, this is how much he'll need to pay. Okay. how much will Andrew have paid over that 1 year total, right? And how much of this is purely from interest? So remember our totals calculation, we can get that by taking our PMT times our N, times our N, times our T. So we take our monthly payment of $117.65, multiply it by 12 and by 1. Okay, so when you multiply that all out, we should be getting $1,411.80. Okay, so that's how much she ends up paying for this laptop. Instead of paying just the $12.49 that it cost on the, the sticker price, instead of just paying that, he pays this much. So how much of that is just the interest? Okay, well, we take that price, or sorry, that amount that he pays, minus the price of the laptop, what he actually paid for. And we end up getting $162.80. Okay. So the idea behind a credit card, it kind of boils down to, hey, I really want this thing right now. I really need this laptop right now because school starts in a week, or I really, our TV broke or stopped working, so I really want to get this TV now. For the cost of having to pay interest, you can do that. You can use your credit card, swipe it, you get to take that thing home with you, and at the cost of some interest, you get to keep it, right? After you pay that price over however long you're paying for, okay? So now in the world of credit cards, Andrew's credit card account says that his minimum required monthly payment, whenever you get a credit card and you get like an online account with it, it's going to tell you this is how much you need to pay every single month, okay? And that's going to be the minimum payment. This is how much you need to pay in order to be in good standing with us. We can't really trust you to keep this credit card if you don't at least pay this much every single month, okay? And that number will depend on how much you have. So the minimum payment will depend on credit card balance. Okay. And so, yeah, this is pretty much the credit card saying, hey, in order for us to trust you, you can pay as much as you want every single month, but you need to at least pay us this much, okay? And so let's kind of see what happens when you only make the minimum payment. How many payments and how long will it take Andrew to pay off this balance if he only makes the minimum payments? Okay, so here's where we're going to use the formula that we came up with at the top. It was N is equal to negative log 1 minus R times P divided by N times PMT divided by log of 1 plus R over N. Okay, so N is going to answer that first part, or solving this will answer that first part, how many payments. So let's go ahead and fill everything in. Our P is still the same, it's 1249. Our PMT is no longer the 117.65. It's now down to $40. Okay, so instead of making $117 payments, we're making $40 payments. Our R is also still the same as 0.2, I already forgot, 2324. And then our N is still 12. Okay, and we don't have a T in here. The T is technically hidden inside the capital N, but we don't really care about that right now. We will here in a little bit when we try to find how long, but let's just find capital N overall. So let's plug everything in. We get negative log of 1 minus. We have in the numerator 0.2324 times our P, which is 1249, over N, which is 12, times 40, which is our PMT. And this is divided by log of 1 plus 0.2324 over 12. Okay, so there's our setup. And just like everything we've done before, calculating this, y'all, is probably going to be a little bit easier if you do it in steps. Okay, so kind of like how, if you did the savings or loans formula, you would calculate this on the side. Same thing here, calculate this on the side. Probably do this first and do 1 minus that. And then we can do log of that divided by log of that with the negative in front of this log, okay? Don't forget about this negative. Try practicing calculating that. You should end up with, your N is 48.38. And here it's 48.38 payments. Okay, so 48.38 payments. Now, as far as kind of, reporting this final answer, we don't want to round it down to 48 because you do need to make more than 48 payments. This 0.38 means we're making part of a payment. So I don't want to round down to 48. We also don't want to round up to 49 because you're not making an entire extra payment after this 48th payment. So the way we'll kind of report this is we'll say 48 full payments. And then plus 1 partial payment. Okay. So that's kind of how much Andrew will need to, that's how many times that Andrew will need to pay in order to pay this loan off. Now, how many years is that going to be? Well, we're making monthly payments, so we're going to divide our 48.38 by 12. So 48.38 divided by 12, that's going to give us about 4.03 years. Okay, so a little over 4 years is how long it's going to take Andrew to pay this off, compared to the 1 year it would have took him if he made these $117 payments. Okay, so the amount of money, money that you use to make a monthly payment really does change up because of this big interest rate. It really does kind of make a difference how much more you'll have to pay. Okay, so how much will Andrew pay overall if he makes only the minimum payments? How much of this is purely from interest? Okay, well, we're going to need to find our total. So our total, remember that's PMT times N. I don't know why this went away. Times N times T. Okay, or another way to calculate the total is taking PMT and multiplying that by capital N, since N times T is capital N. Okay, and we have, we have a nice number for N. We have 48.38. This will take into account that we're making more than just the 48 whole number payments. We're making 48 and a little bit more. Okay, so our total is going to be $40 times 48.38 payments. Okay, and that's going to give us a total of $1,935 with 20 cents. Okay, which means that our interest is going to be that value minus the price of the computer or the laptop, which was $1,249. And that comes out to $686.20. Okay, so just like we've seen before, okay, we know that when it comes to loans, there are lots of different ways we can kind of cut down on the amount of interest that we end up paying, right? One of the ways we looked at in the last section we covered is by making a down payment, okay? And now in this one, kind of what the other way we reinforced here with 5.7 is by just making bigger payments, okay? Now, sometimes that's not possible. Sometimes we can't afford to make bigger payments, but it's just knowing that making bigger payments will cut down the amount of interest, going from $686 interest to just $162, okay? That's $500 less that you had to pay. All right, hopefully this sounds good. You guys will be talking about credit cards plenty once we hop into our project after this last section, okay? Hopefully this sounds good. Let me know if you have questions in class. I will see you in the next one.